All right, so we have to do this practice for our performance task. Basically, what you're going to do is graph some triangles and then show that they're going to be congruent. So if I take this one, A has already been plotted. You can see that negative 5, 2 is A. And then from A, I'm going to go 4 miles east to arrive at B. So if I'm going to go 1, 2, 3, 4, B is right. B is right there. Okay. And then I'm going to draw an angle or a line. Okay. There's my line. Now, so this is B. And then from B, I'm going to go 3 miles north to C. So right there is C. So I'm going to draw my line to C. Okay. And now that says that I return home to A. So again, I'm going to connect the hypotenuse now. This is actually a right triangle. I'm going to connect the hypotenuse. There's my hypotenuse. Okay. And then that, nope, I want to mess it up. Sorry. Okay. All right. Now that's the first part. The second part, it says that Frank is at F. So here's F is actually plotted up there. It says walks 3 miles west. So 1, 2, 3. There's 3 miles west. And that's G. And then he goes 4 miles south to H. 2, 3, 4. There's H. Okay. And let me get it to where I can actually see that it's H. Okay. There's H. Now I need to connect my points. So, and then right? And then again, there's my right triangle. Sorry, right triangle. And remember, this was 3, and this was 4. This is 3, and this is 4. Okay? Now, it says demonstrate that the triangles formed by their roots are congruent. Include a congruent statement and a theorem. So I'm going to show that GF is congruent to CB. So we're going to write that on our statement. GF is congruent to BC. Okay? Because it's given that they're 3 units. So their length is 3 units. Okay? And then it says that I'm going to do BA. So BA is congruent to GH. And that's because the length is 4 units. Okay? And we just counted those 1, 2, 3, 4. Now, what I can't say without showing math is that AC is congruent to HF. Now, in order to do that, so I counted 3 and 4 because we know the distance formula, or this is about the distance formula, but if I use the Pythagorean theorem, I can get the same thing. If I do this length, HF is equal to the Pythagorean theorem. Okay, and that's going to be 3 squared plus 4 squared. That's going to be equal to 9 plus 16, So that's the square root of 25, which is equal to 5. And then I'm going to show that AC is equal to the square root of 3 squared plus 4 squared, and that's equal to 5. So both the lengths are the same. Therefore, I can say that triangle ABC, and I'm going in order, so triangle ABC, and then I'm going to go GABC, and then HGF are congruent by side, side, side. Okay? 2 tick marks, 3, 1, 2, 3. 3 tick marks. This one's going to be a little bit more difficult because it doesn't give me anything. It's not giving me any directions, east or west. It's just giving me points. So the first thing I'm going to do is do the first one. Abe starts at negative 5, 2. So negative 5, 2. 1, 2, 3, 4, 5, 2. That's A. Okay. The library is at negative 3, 1. So if I go 1, 2, 3, 1, there's the library L. And then he walks to Joe's house, which is at negative 1, negative 2. And that's going to be at J. Okay. Now I'm going to draw in my lines. Okay, that's one. Now I need to draw the second one in. Okay, I'm going to put that one. I'll do that one in red. This one is going to be at 4, 5. So 1, 2, 3, 4, 5. So that's going to be point F. And then I'm going to have point S, which is 2, 2. There's point S. And then I have P, 0, 5. 0, 1, 2, 3, 4, 5. And that's going to be at point P. Okay. And draw my triangle. Okay, now I have my triangle. Now, I can see something really easily here, that if I count AJ, 1, 2, 3, 3, 4, so AJ is congruent to PF because PF is 1, 2, 3, 4. PF and AJ are congruent because they are both 4 units. Okay? Now, they're 4 units in length. But the other two I'm going to have to show with the distance formula or whatever else I'm going to have to show in order to move this on, okay? Or to find that we're going to show that AL is congruent to, so if we flip this, PS, so we'll show that AL is congruent to PS. Now, in order to do that, I'm going to have to use the distance formula. But if you're in my class, you know that we don't do the distance formula. I don't like the distance formula. I always do right triangles. So in order to find this hypotenuse, I create a right triangle, and that's 2, and that's 3. So AL is equal to 2 squared plus 3 squared, which is equal to the square root of 13. Now, if if PS is the square root of 13, then I'm good to go. So let's see if it is. So PS is equal to, now, again, I want to make my right triangle. That way I can use Pythagorean theorem. So this is 3, and that's 2. So I have the square root of 2 squared plus 3 squared, and that's equal to the square root of 13. Okay? So that checks. Those are congruent. The last one I have to do is LJ. So LJ is congruent to P or SF. Okay? And then I just have to do the same thing. Again, I'm going to draw a right triangle. So it's 2 by 3. And by now you should be able to see this pattern. So LJ is equal to the square root of 2 squared plus 3 squared, which is equal to the square root 13. And then I've got SF is equal to the square root. And again, if I come up here and I do my Pythagorean theorem, that's 2 by 3. So a side length of 2 and a side length of 3. So I have 2 squared plus 3 squared is equal to the square root of 13. So this is actually an isosceles triangle. Okay, so those work. Those are actually congruent. And then I can say that triangle ALJ is congruent to PSF. And that's by side, side, side. Okay, so on this one, we're going to have to plot the points and then draw our lines that intersect and then try to figure out if we're congruent or not. And we'll end up having to use the distance formula or Pythagorean, whatever we want to use here. So let's do this. I've got negative, A is at negative 1, 5. So negative 1, just a minute. Negative 1, 5. There we go. That's A. And then I've got B is at 1, 1. So B is at 1, 1. That's B. C is at negative 3, 2. So 1, 2, 3, 2. This is C. And then D is at 3, 4. 1, 2, 3, 3, 4. This is going to be at D. And then E is at 0, 3. So 1, 2, 3. There's E. Okay. Now this is B. And it says that AB and CD intersect at E. So this is what this looks like. And then I've got this other one. There we go. And now, here's what you got to be careful of. It says that ACE, so ACE, hang on. ACE and BDE. So there's the triangles I have. Remember, that middle piece is E. Okay? Now, what I'm going to have, let's look at this. I can do this by side, 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 but I'm not going to because that way I don't have to do 3 different distance formula problems. I'm going to do side, angle, side. Remember that those 2 are vertical angles. So if I do a 2-column proof, if I set up a 2-column proof, okay, I'm going to have a statement and a reason. Okay, so the first thing I'm going to do is talk about this vertical angle, AEC. So I have an angle, AEC is congruent to angle BED. That's because of vertical angles. Okay. Now, I need to do some work on some sides. Okay, BD and CA are relevant to me right now because that's not what I want to do since I've got the angles, vertical angles. So what I'm going to have to show is that BE is congruent to AE and CE is congruent to ED. That way I have angles, side angle side. So I'm going to do, again, I don't like doing anything but the distance formula. I mean the Pythagorean theorem. So here's what it looks like when I do this. I'm going to show that CE is congruent to CE is congruent to DE right now. And I'm going to create the right triangle for this. So CE, my length of CE, it's 1 unit by 3 units. There's my right triangle. And there's my hypotenuse. Okay? So I've got 3 squared plus 1 squared is equal to the square root of 10. So that's 3 squared is 9 and 1 is 10. Okay? Then I've got DE. And same thing with DE. I've got 1 unit up and then 1, 2, 3 units over. So I'm going to be at 3 squared plus 1 squared is the square root of 10. So that shows that I have DE is congruent to CE. So I'm going to make that statement. Number 1, let's see, that was 1. This is 1. Here's 2. I'm going to say that CE is congruent to DE. Okay. And the reason being, it's just the Pythagorean theorem. The distances are the same. Okay. Now, I've shown that. So now I need to go back up in here and show that AE is congruent to BE. Okay, I'm going to see if I can erase some of this stuff because I've got a lot of junk going on in here now. Okay. Remember, I've got this is congruent to this, and now we're trying to show that these two are congruent. Okay. All right. Now, I'm going to again create my right triangle. So I've got 2 by 1. Okay. So BE is equal to the square root of 2 squared plus 1 squared, which is the square root of 5. And then A is a 1, and then it's down 2. So 1 and 2. So AE is equal to 2 squared plus 1 squared is equal to the square root of 5. So now, by distance, I see that those are actually going to be congruent. Okay? I'm going to erase some of this mess all through here and kind of put our images back in. Remember, let's see, this is E, and then my angles were equal. I showed that AE is congruent, and I showed that CE is congruent to ED. The last thing I need to do is make my statement. Okay? So we've got the third statement. I'll keep this red. That way we just stay tight. So we've got 3, and that's going to be AE is congruent to BE. And again, that's because of the Pythagorean theorem. Okay? And then the last statement is the similarity or the proof statement. And I'm going to use what I did up here, AEC and BED. It keeps everything in line. Okay, so I've got triangle AEC is congruent to triangle BED, and that's by side, angle, side.